The final topic I'd like to talk about is variation of parameter, and we did only one part. It was about finding a second solution of homogeneous equation if we know one of them. This is often called reduction of order because we begin with second order. With this method, we end up with first order equation. y2 is equal to u times y1, and this parameter is something we want to identify. How do we do that? Well, calculate the derivatives and plug those to the original equation and work out. It'll turn out that you're going to get a first order equation of u prime and find out using integrating factor, and then take the antiderivative yet again to find out u. That's how you do it. Now let's go over to another one, finding a particular solution. If you have y1 and y2, which are solutions of homogeneous equations, you can set particular solution as u1 y1 plus u2 y2. u1 is a parameter that you have to find out. u2 is another parameter that you have to find out. If those u1 and u2 are not parameters but just constants, then this will be just linear combination c1 y1 plus c2 y2. So instead of having a particular solution of non-homogeneous equation, you're going to get another solution of homogeneous equation. No good. So it is absolutely necessary this u1 and u2 are parameters with some non-trivial t terms. And then let's go with another restriction here, u1 prime y1 plus u2 prime times y2. Why do we do it? Just for simplicity, as a matter of fact. You'll see your computation will become a little bit simpler because of this. But still, very often this method fails. More often than not, as a matter of fact, this fails. Still, compared with really large class of differential equations that cannot be solved at all by any kind of analytic means, if there's some method that works for many classes, that's good enough for me, and that's the strength of this variation of parameter. u1 y1 plus u2 y2 and this additional restriction put together, and we end up with some beautiful method. Let's go with an example problem here. Let's begin with an equation that we encountered before. ty double prime plus 2y prime plus ty is equal to 0. In that case, we had solutions of homogeneous equations like this. y1 is cosine of t over t, y2 is sine of t over t. Look at page 333 of our textbook. We can check these there. Now we're going to use these and variation of parameter to find out a particular solution. How do we do that? Here's the first setup. Particular solution is u1 y1 plus u2 y2. And then another restriction here. u1 prime y1 plus u2 prime y2 is equal to 0. Excuse me, I forgot my indices here. Okay, all right. Okay, now that we have y given like this, u1 y1, u2 y2, let's find out the derivatives so that I can plug everything into this equation here. First derivative computation, we just use product rule. u1 y1, if you calculate using the product rule, we get that. u2 y2, again product rule. Now please note the green part, u1 prime y1, u2 prime y2 add up to 0. And what's left is the black part. So the first derivative turns out to be u1 y1 prime, u2 y2 prime. Alright, that's something we're going to put over here. Next, second derivative. What choice do we have? Another product rule. Another product rule. And that's going to go right here. if you do put those in, you're going to end up with, holy cow, this expression. Well, let's see. Ty double prime plus 2y prime plus ty. Oh no, this is not it. Ty double prime plus 2y prime plus ty is equal to 1. That's the original equation. And we are going to put in y double prime and y prime and y like this, here, here, and there, and that's how we get second derivative, first derivative, and the original. So that's the second line here. Now let's do something ingenious. Let's take all the terms with u1 right here, and then u1 and u1 put together, u1 and the other three. What did you get? Ty1 double prime plus 2y1 prime plus ty1. That's 0 because y1 came from this solution of homogeneous equation. Let's look at this again. This one, this one, and this one. And then take this u1 out. What's left will be y1 double prime times t. So here we go. Next, y1 prime times 2. So it's this one. And how about this? y1 times t. y1 times t. While u1 is common to everything. Look at this blue part. The coefficient part of this u1. Ty1 double prime plus 2y1 prime plus ty1 is equal to 0 because y1 is the solution of the homogeneous equation. You can do something similar for the terms with y2s, as a matter of fact. Here's one, here's another, and then here's the third. And then this is y2 double prime plus t, so we're going to get this term. And then y2 prime times 2, so we're going to get this term. And finally, this y2 times t, that'll give me the last term. And what did I end up with? Again, the same deal, that add up to 0. So what's left is only this part, and that is equal to 1, the non-homogeneous part, the right-hand side. Let's recap. Due to all these restrictions, what did he end up with? This is equal to 1, and here goes one equation. And then recall the second equation. I ended up closing this prematurely. Second equation there. Yes. u1 prime y1, u2 prime y2. That is equal to 0. So that came from the second restriction, which we started off from the beginning. and that one came from this computation. So what do we have? We have two equations and two unknowns, u1 prime and u2 prime, because we know y1, y2, and y1 prime, y2 prime. So two equations and two unknown, we can solve it. Okay, how about this green equation? Y1 and y2 are cosine of t over t, sine of t over t respectively, so we get that. And then this one, well, y1 prime is this one by quotient rule. Y2 prime is that one again by quotient rule. Complicated, but we have equations. Let's simplify these equations. The first one is relatively easy to simplify. Let's remove the denominator by multiplying everything by t, then we get that. A little bit simpler. This one, let's work it out. Remove all the denominators by multiplying by t squared, and multiply t squared there. T squared times 1 over t, I'm going to get equal to t. So we have green and red in a little bit more simplified form. But let's work on it a little bit further. Break up all the parentheses. And then please note that this one, cosine of t times u1 prime, sine of t times u1 prime, came precise from here, which I highlighted in green here and there. So they add up to 0. And thus what's left is the black part. This plus that is equal to t. And finally, please note that each term has t, so divide everything by t, and then we end up with this equation. So we have green and red. System of linear equations, and no denominator, relatively simple. Let's work those out. This and that. Okay, brute force computation. Let's remove, let's see, u2's, this one and that one out. Okay, multiply cosine of t here, multiply sine of t there. Multiply cosine, multiply sine, and then, not that, multiply cosine and multiply negative sine, yes, and add them together. So u1 part is cosine squared plus sine squared, and then u2 part cancel out. Right hand side, 0 times negative sine, add them up. This is what you get. u1 prime is negative sine of t, because this whole thing is equal to 1. Next, from here, multiply by sine of t. Here, multiply by cosine, and add them up. Multiply by sine, multiply by cosine, add them up. That'll kill up the u1s. This one and that one away. And then what do you have left here? Cosine squared plus sine squared times u2 prime is equal to cosine. This is 1, so what do you get? u2 prime is cosine. Finally, we have it. u1 prime, u2 prime. Therefore, upon taking antiderivative, you get u1 is cosine, u2 is sine. Whew, almost there. So, u1 is cosine, u2 is sine. Okay, let's put those in. Cosine times y1, sine times y2. And let's simplify. The numerator becomes cosine squared plus sine squared, which is 1. So what did we get? We got 1 over t. That is the particular solution. And so general solution is c1 times cosine of t over t plus c2 times sine of t over t. Those are general parts. And then particular solution 1 over t. Let's see. And then y of t is, let's clear a and b as well. A cosine of t over t plus b sine of t over t, homogeneous part, plus 1 over t, that's my function. And then let's get the differential equation. What was the original differential equation? I don't remember. Let's copy and paste it down here. And then, okay, so it's t times y double prime plus 2y prime plus t times y, and simplify all that. Am I going to get the right hand side, which is equal to 1? Yes, we did. So what's the conclusion? We successfully got the general solution here, as we see over here. And let's put all these together. And that'll complete this notebook. We just completed this problem using the variation of parameter. Long process, but I have to say variation of parameter is an important technique. Long, but it's an important technique.